Okay, guys. So today I'm going to walk you through the evolution of software architecture. So I'm Priyal. I have more than 15 years of experience in this domain. So what I'm going to do today is I'm going to take one of the projects that I did for like many years, and I'm going to present you how that particular software's architecture been evolved throughout many years of period. Okay, so to begin with, first of all, we'll define what is the software architecture. Now, there are a lot of arguments and a lot of contradicting definitions to this, but I have taken this particular definition from the book called Fundamentals of Software Architecture. So, according to that, the software architecture has mainly four features. That is the software structure and the architecture decisions, architecture characteristics, and design principles. So the software architecture would compromise all these four factors. So in this particular lesson, what I'm going to walk you through is only the software structure part of this architecture. Okay, so we began from Monolith. So now you may ask why we have began from Monolith. We had like a lot of different architecture styles and all. But mind you that, this particular project has started as a pre-sale project. So if you're doing a pre-sale project, or if you're doing a throwaway prototype, or even at least if you're doing a campus assignment, so in that kind of situations that you are not focusing mainly on high-end software architecture patterns and styles and all that. So what you are focusing is on an MVP or minimal viable project. So what because you need to cater your clients' requirements as soon as possible. So we also began like that. So we published our project using this monolith into the production. So we lived with this production for a few months. And then, many people tried to get on board with our platform. So then we had the problems of scalability, elasticity, and resilience, and all that. So then what we tried to do was we identified, which part, which module that users are using more oftenly, and then we dissect or take out that particular component from our main monolith. And of course that we have exposed that as a REST API. So we have our web API, or sorry, the web front end here. So this one was an Angular application. So even from the front end that we had to maintain like two endpoints. One is pointing into our main monolith, another one is pointing into uh, our newly created service. So mind you that we are still sharing the database in between the monolith and the new services. So what we did was we have scaled this particular part into many services. So we have hosted this thing in AWS. So we have container. We created so many containers of this particular service and scaled it according to our client needs. So then we proved that this particular model is kind of like success. So then we one by one take out all these parts from the main monolith and spin up independent services. So still you can see that our end needs to make many endpoints, and still the database is also being shared. So what are the uh, drawbacks of this system as it is now? So one drawback is the deployment. You know that deploying a monolith is kind of like it is a bit of a troublesome thing, because you need to deploy or release all your components at once. So because the database is shared in between these services, if let's say for example service contain some changes which required a database change, then all these services needs to get deployed, because once the schema changed, it would affect to other services as well. And the other problem that we had was that the front end needs to maintain many endpoints. So to cater that, we have introduced the API gateway. So in this case, the front end web application needs to like concentrate only on one endpoint, and the API gateway has the knowledge of how to routing or distribute these API requests into the correct endpoint in the backend. So, and apart from that, API gateway handles the authentication part as well, because we have used the OAuth for authentication. So the API gateway did the routing and the authentication in this stage. Still, I would I like to address this one as a distributed monolith, because still, that we cannot deploy, even though that we have these independent services, we cannot deploy these services independently, because if there's a schema change, then we have to deploy all the services together. So that's why that still I address this one as a monolith. But the system been improved, whatever we identified, whatever the bottleneck areas, and then we spin off a new API service using that bottleneck areas. So then we moved along, and then at the end we managed to spin off more than 50 services from the monolith itself. So you can see that the monolith is still there. Due to many reasons, we were unable to port all the monolith components into different services. So I mean, this is kind of like a common thing when you are migrating from monolith to any other architecture. There might be chances that you can get rid of your monolith at all, but there's a high chance that you still needs to live with your monolith, even if you are going ahead with other newly created services. So you might think that, okay, isn't this microservice? So why I address this thing as a distributed SOA, or distributed service oriented architecture? Because still you can see that we are sharing our database, right? So still the problem is there. I mean, if the change or patch update has something to do with database scheme or schema, then we have to release all the components or services together. So still the deployment is kind of like a headache to our DevOps team. So then what we did was, we managed to dissect our main database into independent databases for each of the services. Actually, guys, this is one of the key turning points in our product, because this one, it was not hard. Like we had to do a lot of POCs, we had to do a lot of discussions, we had to do a lot of data migrations. Like we know, because we are dealing with production grade data, live data. So then we have to be very careful with data, but still we need to do that change as well. Because if I go back a little bit to the previous slide, one drawback with the sharing database is that, okay, now as I explained to you earlier, that we can scale the API gateway, we can independently scale these independent services. Even in the monolith, we manage to scale it up to some limit, but in terms of performance and scalability, still database is a problem. Even though that we managed to get independent request independently from to these services, still database creates a kind of like a bottleneck. So that's why that even with all the hardships, that we managed to dissect the database into several services. Okay, the main problem that we had with this distributed SOA is that the intercall or the inter-service service calls, right? So because that if you take this particular service, independent service, you cannot, if there's a dependency with the data in this database, you cannot call this database directly. Of course, technically we can, but according to these service-oriented architecture protocols, we cannot call directly to another database. That violates the protocol. So then what we have to, you have to go through the service and come to the database. So because of this, there are a lot of inter-service calls are there. Most of them are exposed as REST API. Some of them are exposed as sockets. But there are a lot of inter-service calls going on. So because of this, there's a heavy chattiness in between these services. As I remember, there was one particular API call, and in order to fulfill that, we had to have like more than 25 hops in between these services. So it takes time, it hinders our performance a lot. So in order to cater this problem, we have introduced an event bus. So even though that I have exposed this as an event bus, the actual implementation was a Kafka message broker. So whenever, so now, this particular architecture now moving into from SOA to event-driven architecture. So if whenever a request comes, so the event bus absorbs that. Actually, on the API gateway, publish that thing into a correct Kafka topic, and then whoever the subscribers of that Kafka topic into that event and fulfill that event. So even the response was like whenever these services fulfill that particular whatever the request, then the response is being sent to a different Kafka topic, and it goes on like that. So because of this, we managed to uh, get rid of the high coupling in between these services. So the services became more independent. So even when it comes to deployment, now for the first time, we managed to deploy these services independently. I mean, let's say for an example, if there's a change or enhancement or patch update into this particular service, we can deploy it independently, irrespective of other services. Because the reason is that even though there is a schema change, the schema change is private to that private database, and it won't directly call to any other services. So there's the coupling is being minimized in here, and the cohesion being improved. So so this is the next step that we did. Like, so this one we identified as a event driven architecture. So you might raise a question that isn't this the microservices architecture, because we have independently deployable microservices. So why can't we define this one as a microservices architecture? The reason is this: in order to make this microservices architecture, we have to have a lot of other supporting functionalities. Eventually we end up with more than 50 services like this. Right? The main problem that we had was like maintaining these services. Whenever the one particular service gone down, we don't know whether it's gone down or up. Other thing is that whenever that we need to do scaling, we don't know exactly how to do the scaling, how much instances that we should have. The other thing is the other main problem that we had encountered was the exception handling and error tracing, because whenever that this our API gateway publish an event into this event bus, there are a lot of services get involved into fulfill this uh, that particular request. So sometimes if an error comes, we get lost the trace. We don't know where the error originated. So there are a lot of problems in this particular architecture as well where we have encountered. So in order to remedy that, first thing that we have introduced was service discovery. So this service discovery is a service that where you can monitor all your services. Whenever a service goes down, there are alert systems and all that, and even self healing system was introduced, so then it can spin up new instances of that from that particular service. And distributed logging and tracing, this one I have explained earlier. Whenever that API gateway or front end send a request, what we did was it's been associated with the correlation ID or CID. So then throughout, from starting point to end point of a particular request, so then we have, I mean, we could have trace the trace that particular action from starting to endpoint. So that's been enabled by distributed logging and tracing. You can use tools like such as Jagger and all to do this thing. And the fault tolerance and circuit breakers. Whenever service goes down, we should not load that service. So there should be a circuit breaker to notify, okay, the service is down, don't call that service again. So whenever that service comes back again, there should be a service, actually, service discovery should get notified, okay, the service is up. And the other thing is that the whenever that we need to do high scalable architectures, or whenever that we need to do elasticity, whenever new users are coming up or a lot of users are coming up, so that also help with service discovery and circuit breakers. And the other thing is that testing. We have like more than 50 services at this point. So manual testing all these services and the front end is kind of like out of the scope at this point. right? So whenever that, assume that you are doing a deployment of more than 50 or 25 or 50 services, you have to you have to automate everything from automation testing to integration testing to QA QA automation testing as well, API testing and all that. So we have to automate all these things. Otherwise, you can't live with this architecture. Right? And other one is a CI/CD. You cannot deploy 25 services at once, right? Whenever a new release is been going on or a new production release is going on. We have introduced continuous integration and continuous deployment pipelines. So this one is very easy to do when you have very small independent services. So we have leveraged that. The other one is the container orchestration. We have used Docker to host most of these instances. So the container orchestration being handled by Kubernetes at that point. So you have to have all these functions. I mean, there are many more as well. In order to call this thing as an EDM or event-driven microservices. So if you do not have these supporting functionalities, it is not a good idea to call that you have microservices, right? Otherwise, you will be end up in a pitfall where you cannot, where it will be hard to get over from that pitfall if you come across a problem. So the next problem we had was something different now. So now, yeah, now we have the EDM, so everything is working fine. The resiliency is there, the elasticity is there, scalability is there, the performance is, most users are happy with the performance. But after some time, we engaged something like a very unique problem. So that problem is that we identified one particular database or one particular service per se is not performing, even though that we have the scaling and all, not performing very well as an independent service. So then we identified the root cause. The root cause was that there are high database reads. So then, to overcome that problem, what we did was we introduced, after doing some research, we introduced some indexes. So that improved the readability of that database a lot. So the service performance has increased. But this database has a different aspect as well. So there are a lot of writes into this database as well. So because of that, because we have introduced a lot of indexes, the write performance has decreased a lot. So we have to, from the event bus, whenever that the service consumes an event from that event bus or the Kafka topic, so then it takes a lot of time to do a write. So then what we did was we came up with the command query responsibility segregation principle, or CQRS. So what we did was we separated our read database and our write database. So there is a replication in between these two databases. So one aspect is that the data would be like eventual consistency. Then we have moved into eventual consistency, because whenever that you write into this particular database, so there are no indexes in the command database. Only whatever things that is required for the writing, and this query database has a lot of indexes optimized for readings. Now everything is fine in the back end. We can do independent deployments. There's a scalability is there, the elasticity is there, the resilience is there, everything is there. It's kind of like perfect world in the back end side of the architecture. But how about the front end? We have still, it is kind of like a monolith SPA that we are using. We have used Angular in this our front end as our front end technology. So, but whenever that we need to, there's a change in the front end, we have to deploy all the front end at once, because everything is kind of like a monolith. So then what we did was we segregated our front end into different front ends. So this one is called as micro front ends. So we have used the framework called single SPA, and apart from that, there are other frameworks as well that you can use. So what it enabled, so actually it enabled a nice thing. So it enabled this team structure, right? So there are one or many UIs that is being communicated with the backend service. So we can, create. I mean, we have been able to create one particular team to maintain that business part or the business module of that part of the application, right? So and the other part is that, I mean, we had like, we had development teams over, span across 3 countries actually. So easily we can offload one business functionality for one particular team in a one country. So that, that enable the business, the development scalability as well, or the developer experiences as well. So, and the other thing is that the composition. So, there are like 3 compositions that we can use here. That is the server-side composition, the front-end composition, and the CDN level composition. So, we have used the front-end composition here with the tool called single SPA. So, that enabled us to deploy the UI components separately as well. So whenever that there's a change, we can isolate that particular UI part and get it deployed with if there's a backend changes as well. So then we can deploy it together as a single application. So but for the user, it's same. Whenever user logs into our website, it looks same, even though that the UI components are coming from different UI applications. So this is kind of like, a roadmap that we had in our architecture. So I hope you got something from this presentation where you can use some technologies into your architecture as well in order to, improve the architectural features such as the resilience, performance, elasticity, and all that. So I like to, give some references to you as well. So I have used some content from one of few of these books into this presentation. So these are, like very good books that I can recommend you to read about the current or modern software architectures. Okay, so thank you for listening to my presentation. I hope it helped to improve your knowledge at least some small limit.